Felt is a material and a process that's thousands of years old, that started with taking the hair from animals and tangling it into a matted surface. But in most cases, it's always a flat sheet. That sheet can be yardage that could be rolled like fabric, or it could be a rigid board. And our goal with this project was to see if we could make complex objects that would have varying thicknesses, going directly from fiber to object, not stopping in the middle with a sheet of material. And what we proposed to do was to develop an apparatus, what's called an end effector for a robot, that could be as nimble as the hand of a felting artist, but as precise as a machine tool. Both of those new to what felt could be. There has been research and collaboration between mostly architects and computer scientists doing felting, but it's very much in the same paradigm that 3D printing works. It's basically using a Cartesian grid and creating relief. What we're trying to do is to create things that might be bowl-like, fully three-dimensional, like the shell of a one-piece chair or a shoe. Imagine if someday we could take this raw filament that came from recycled bottles, turn that filament into an object where you would grow it from the ground up, not that different than the way a caterpillar might produce a cocoon. And in this case, that cocoon that holds your foot would be high performance. It would have regions that are really dense, regions that are really soft. We would even gel some of the resin and make it a solid to make hard and grippy surfaces. And then when the object is through its useful life, the goal is, if it was PET, that actually you could just take that shoe and turn it back into another PET object, because it's not contaminated. It's a single material, even though it has the behavior of many. Working with a mechanical engineer, Dr. Alan Asbeck, and with California-based artist Stephanie Metz, we've been collaborating on both the kind of conversation around how this technology could be applied, brainstorming what kinds of work could come out of it. The engineers are really interested in kind of the first fundamental steps of the research. Can we make a swatch that has, a sine curve on the top and a flat bottom in varying densities? The artist, on the other hand, is like, I want to go big, I want to make art, and I need faster and bigger hands than my own. I'm interested in thinking about how we can use making her art as a way to learn how to make other objects, because art is very undefined. The lack of definition means that we're going to learn on the fly. We're going to fail forward, see how the technology might work or not work. But the dialogue between engineers and artists to kind of understand how those two things might relate is one of the interesting challenges of collaborating on a diverse team. Sometimes the project goes incredibly well, and what I really appreciate about ICAD is I haven't felt much difference in expectation. They expect that you're responsible with their support, but sometimes that means you fail. It's really amazing to have an open conversation with other people interested in technology and creativity about how we might see a different future.